Hey everybody, Chris McClure here again. We are going to have a quick review on roots and powers. Okay, so here we go. We're going to talk about taking roots first. Now, when we take the nth root of a number, like you see right here, and we say that the nth root of a, for example, where a is some number, the nth root of a is equal to b, means the same thing as that a is equal to b to the nth power. So for example, when we take cube root of 8, what we're looking for is the number whose cube is equal to 8. Okay? So you can think about 8 as 2 cubed, and the cube root of 2 cubed is 2. Why? Because 2 cubed is equal to 8. That's why. How about cube root of negative 64? What number cubed is equal to negative 64? And that answer is negative 4, because negative 4 cubed is equal to negative 64. The fourth root of 1/16, we're looking for the number whose fourth power is equal to 1/16. So the answer is 1/2, because 1/2 raised to the fourth power is equal to 1/6. So you can see the relationship between roots and powers that are exactly the same. They're kind of inverse operations of each other. So fourth roots and fourth powers are inverse functions of each other. How about the sixth root of negative 2 raised to the sixth power? Now look, when we take even roots, as in roots whose index is an even number, well, the result is going to always be a positive number. So when we, in the radical, we have negative 2 raised to the sixth power, that result is going to be a positive number. And then, of course, the root of a positive number is a positive number. And in general, when you're taking the nth root of any number to that same power as the index for the root that you're taking, the result is taking really the absolute value of that number that you had risen to the power within the radical. A little bit confusing at first, but just understand that the result of taking any root, any even root, I should say, is a non-negative number. Now, when you take odd roots of negative numbers, the result will be negative numbers. But when you're taking even roots, the result is always going to be some non-negative number. Now, negative 2 in this example raised to the sixth power, negative 2 raised to the sixth power, is a positive number. It's the same as 2 to the sixth power. And of course, the sixth root of 2 to the sixth power is 2. Same thing. Alright, so generally speaking, nth root of a to the n is a, provided that the index n is odd. But if you're taking even roots of even powers, and the power and root is the same index of a, then the result is the absolute value of a. Okay? Moving along here. Now, how do you do roots on your calculator? Well, let me pull out my calculator. I've got my friendly little calculator here. So, if I wanted to do, say, the fifth root of 16, well, what I could do is use a fractional exponent of 1/5. So I could do 16 raised to the 1/5 power. And that's how we can evaluate the fifth root of a number, for example. Now, some calculators have this x root functionality, but not all TI-83s and TI-84s have it. It depends on how new your calculator is. But like I said, you might, for a newer version of this calculator, might have a key where you can access the x root. Otherwise, just use fractional powers to calculate your root. Okay? All right, let's talk about simplifying radicals. That basically means pull out as much stuff from under the radical sign that you can. And also, it means combining any radicals that you can. Now, here's some general properties for you to look for. The nth root of a times b is the same as nth root of a times nth root of b, and vice versa. Nth root of a over b is nth root of a divided by nth root of b. Now, if you're taking a root of a power of a, the nth root of a to the m power, well, look, you could do the root first and then the power, or you could do the power first and then the root. Okay? You can interchange them. So let's just put that to the test here, see what we could do in simplifying these radicals. How about the square root of 32? What can we do with that one? Well, what you're going to look for is identifying any perfect squares of the radical, within the radical. So within 32, which is the radicand. So are there any perfect squares? Well, 32 factored could be written as 2 times 16. 16 is a perfect square. It's 4 squared. So you can rewrite square root of 16 times 2 as square root of 16 times square root of 2. And square root of 16 is 4. So this radical square root of 32 could be simplified to 4 times the square root of 2. All right, here's our next example, cube root of 16. This time, as you look at the radicand, 16, are there any perfect cubed factors of 16? Well, I could think of one, namely 8. 8 is 2 cubed. So write 16 as 2 times 8, and then write this radical as cube root of 8 times cube root of 2. Now, cube root of 2 is 2 times cube root of 2. So 2 times cube root of 2 is what cube root of 16 is simplified. You know that your radical is simplified if you cannot pull out any more perfect cubes out from under the radical sign. Sorry about that, I got an itchy nose. All right, here's our next example, cube root of negative 16 times x to the 4th power. Are there any perfect cubes under the radical sign? And the answer is yes. Now, 16 could be written as 2 times negative 8. And negative 8 is negative 2 cubed. So negative 8 is a perfect cube. Also, x to the 4th power could be written as x cubed times x. So negative 8 times x cubed can be combined together to make a perfect cube. As in, negative 8x cubed is the same thing as negative 2x cubed. And then times 2x, which is the stuff that's left over there and there. So then you could pull out the negative 2x cubed and then you're left with the cube root of 2x. Okay? Moving on here. Now, here's something a little bit more complicated, but the concept is still the same. Here we are dealing with the 4th root of 16 times x to the 5th power over 81. We are looking for numbers whose 4th power appear as factors here. Now, I know that 16 is 2 to the 4th power. And I could also write x to the 5th as x to the 4th power times x. And 81 is 3 to the 4th power. So you got your 2 to the 4th times x to the 4th over 3 to the 4th. You can combine those as 2x over 3 raised to the 4th power. And then times your x there. And then you can pull out that 2x over 3 raised to the 4th power. But be careful as you pull it out, as you are pulling that out from under the 4th root sign, you have to make sure that you take the absolute value. Now we know that 2/3 itself is positive, but we don't know about x. So you could just as well express this answer here as 2/3 times absolute value of x times 4th root of x. Okay? Moving along here. Now, we could also simplify radical expressions by combining radical terms. By simplifying each of the terms. Now, we have negative 8 times square root of 12 plus square root of 3. Let's simplify the negative 8 square root of 12. Now, the square root of 12, of course, can be written as square root of 4 times 3, but 4 is a perfect square, so you can pull out the 4, leaving you with, now, square root of 4 is 2, so you have 2 times negative 8 is negative 16. So you have negative 16 times square root of 3 plus the square root of 3 here. And notice that you've got like radical terms with the common factor of square root of 3. And so all you need to do now is just, do kind of the reverse of the distributive property. You can kind of factor out the square root of 3, so you have negative 16 plus 1 times square root of 3. So it will give you the negative 15 square root of 3. Okay? Here's another example here. Cube root of 8 times x to the 4th power plus cube root of negative x plus 4 times cube root of 27x. So for each one of these terms, pull out whatever you can. Pull out any perfect cubes, and let's see what you get. Now, the cube root of 8 x to the 4th, let's look at that first. Now 8 is 2 cubed. X to the 4th is, well, could be written as x cubed times x. So you have 2x as a perfect cube for the first one. Now for the second term, you could pull out a negative 1, okay? For the third term, you can, think about 27 as 3 cubed there. So you'll be pulling out a 3. So let's go ahead and make our next pass through here. Here we're pulling out a 2x from the first radical, pulling out a negative 1 from the second, pulling out a 3 from the third. All right, so here we go. We've pulled out a 2x from the first term, pulled out a minus 1 from the second term, and then when we pulled out a 3 from that third radical term, cube root of 3 cubed is 3 times 4 is 12. And now we have a common factor of cube root of x. And when we combine these, so you can just focus now on coefficient 2x minus 1 plus 12. You can combine the minus 1 and 12 to make 11. So you're left with 2x plus 11 times cube root of x. Okay? Moving along here. Let's talk about rationalizing denominators. Now, there's going to be a lot of times when we prefer to have fractions involving roots to not appear in the denominator. So, for example, in calculus, it's often accepted for us to write square root of 2 as the sine or the cosine of 45 degrees, for example. But that's going to be the same as square root of 2 over 2, where it's preferable to have some number that is not a radical in the denominator. Okay? So we'll talk about how to get rid of any radicals that are in the denominator of your fraction. Now, how do we do that? Well, depends on what's in the denominator. If you just have a square root or some other radical in the denominator, well, multiply by If you have a square root in the denominator, multiply by that same square root, because the square root of some number times the square root of that number, you'll just have that number. If you have square root plus some number, then multiply by the conjugate of that square root of minus that number. Because of the fact that, in this example, we have cube root of 3 plus 1 times, I'm sorry, I said square root of 3, I should say. Square root of 3 plus 1 times square root of 3 minus 1. And when you multiply this out, you FOIL it out, square root of 3 times square root of 3 is 3. 3 times negative 1 is negative root 3, plus 1 times root 3. 1 times negative 1 is negative 1. And of course, the radical disappear, leaving you with 3 minus 1 is 2. So you take this sum or difference involving a radical and you multiply by that conjugate, and the result is always going to be just a nice real number. So if you have square root of 2 minus 3, then you'll multiply by square root of 2 plus 3. If you have a square root of 5 minus square root of 3, then you'll multiply by square root of 5 plus square root of 3. And the result in all three of these cases is going to be a real number. Now, got to be careful though. If you have cube root of some number, then you have to multiply by another cube root in order to get rid of the whole thing. Now, if you had cube root of 4, in this case, cube root of 4 is equal to cube root of 2 squared. So all you need is another cube root of 2 in order to have cube root of 2 cubed. So if you have cube root of 4 times cube root of 2, that'll give you cube root of 8, which is 2. So if you had cube root of 4 in the denominator, then just multiply top and bottom of the fraction by cube root of 2, and you'll have rationalized the denominator. Alright, so let's do some problems here. First, we have 1 over square root of 3. So what do we multiply this fraction by in order to get some number in the denominator that doesn't have a radical? And the answer is we multiply the fraction by square root of 3 over square root of 3. We're not changing the value of 1 over square root of 3. We're just changing the way that that fraction is expressed so that it doesn't have that square root of 3 in the denominator. Now, of course, you see in the denominator we have square root of 3 squared, which is 3. In the numerator we have square root of 3 over 3. Okay? Second problem here, we have 5 divided by 4 root 2. So we'll multiply this fraction by square root of 2 over square root of 2. So that these two will combine to make 2. Okay? Alright, next fraction here, we have square root of 2 divided by square root of 3 minus 3 root 2. Folks, whenever you have sums or differences of involving radicals, then multiply by some fraction where the numerator and denominator is going to be the conjugate of the denominator of the first fraction. So in this case, we will multiply by this guy right here. We have square root of 3 plus 3 root 2 over square root of 3 plus 3 root 2, which is the conjugate of the denominator of the fraction. All right, now, when you multiply out the denominator, you have difference of squares. Remember, the result will be the difference of squares. Okay, 3 minus 18 is negative 15. Multiply out the numerators, and this is what you get. And of course, you could always pull out the minus sign, okay, out to the front of the fraction. I'm talking about this minus sign right here. You can pull out. Okay. So there you go. We've rationalized the denominator. All right, let's go talk some more about simplifying expressions with radical exponents. We already talked a little bit about earlier where you can take the 5th root of 16 and write that as 16 raised to the 1/5 power. Right? Using fractional exponents or rational exponents to indicate roots and powers. Okay? Now, when we take some number raised to the 1 over n power, that's the same thing as taking the nth root of that number. Now, here's the caveat, provided that that root exists. Remember that you cannot take an even power of a negative number, as in like the 4th root of -2, for example, and still be within the set of real numbers. Okay. Now, if you have 4 raised to the 1/2 power, that means square root of 4, which is 2. If you have 8 raised to the 1/2 power, that means square root of 8, which means 2 root 2. Because you could pull out a 2 from under, you could pull out a 4 from under the radical. 8 is 4 times 2, square root of 4 is 2. Alright, here we've got -27 raised to the 1/3 power. That power of 1/3 means that you're taking the 3rd root of -27. And the result is -3, of course. For part D, we have 16 raised to the 1/3 power, which means cube root of 16. All right, 16 is 2 times 8. 8 is perfect cubed. So you're left with 2 times cube root of 2. All right, the important thing, of course, is recognize what you need to do when you're taking these rational powers of a number. Basically means you're taking some sort of root. Of course, if you have this full fraction a raised to the m over n power, that means that you're taking the nth root and the mth power. So you could do the mth power first and then the nth root, or you could take the nth root first and then the power. Okay? So, for example, if you have 4 to the 3/2 power, now you could write this as 4 cubed raised to the 1/2 power. Now, 4 cubed is 64, and take square root of 64, you get 8. Or, like they show here, you could take the square root of 4 first, which is 2, and then cube it and get 8. So you could do it in either order, and you get the same answer. Part B, you have -8 raised to the 4/3 power, so you could take it to the 4th power first, and then take cube root. Or, hey, you could take the cube root of -8, which is -2, and then raise that to the 4th power, which is 16. Here for part C, we've got 32 raised to the -2/5 power. So you could either take the 5th power of 32 and raise that result to the -2 power, or you could take 32 raised to the -2 power and then take the 5th root of that. Either way. Say if it were me, I'd take the 5th root of 32. Because I know that the 5th root of 32 is 2. And then we could take 2 raised to the -2 power, which is 1/4. Okay? Moving along here. For part D, we have 25 raised to the 6/4 power. Now, if your fraction in the exponent can be reduced, then go ahead and reduce it. 25 raised to the 6/4 power is the same thing as 25 raised to the 3/2 power. Which means that, look, you could take the square root of 25 and then cube it, or vice versa. Now, it looks like for this example solution, we're going to take the square root of 25, which is 5, and then cube it to get 125. Now, let me just show you on the calculator, you could take fractional exponents. I've already shown one example here. And if we wanted to take 25 raised to the -2/3 power, we could do that as well. All right. All right, now we're going to move into a little bit deeper water. We're still simplifying expressions, containing rational exponents. We're going to simplify each expression, and we're going to express our answer so that only positive exponents occur. This is important. Only positive exponents occur. And assume that the variables are positive, so that we don't have to worry about taking even roots of negative numbers and dealing with absolute values. All right, so here we go. Now, as we look at x to the 2/3 power times y times x to the negative 2 times y raised to the 1/2 power. Now, this right here means you have to focus on the second factor first, dealing with that power. So you are going to use the fact that you have a times b raised to some power, call it m. That's the same thing as a to the nth power times b to the nth power. Okay, so you're going to distribute this power of 1/2 to each of the x negative 2 and to the y. Right, like we're doing right here. And then use the fact that a to the nth power in turn raised to the nth power is the same thing as a to the m times the nth power. So the exponents multiply. So here for negative 2 times 1/2, we're going to have negative 1 as the exponent on x. And then we can combine the powers of x to the 2/3 power times x to the negative 1 power, which means that you're going to add the exponents, 2/3 times negative 1. All right, 2/3 plus negative 1, because you're multiplying those powers of x together. Same thing with the y's. You're going to take y times y to the 1/2 power that you see right there. So remember, you're going to add those exponents. 2/3 plus negative 1 is negative 1/3. And 1 plus 1/2 is 3/2. So here's the result right here of simplifying this expression here. Okay? A little bit complicated at first, but just take it one step at a time. For part B, we have 2 times x to the 1/3 power over y to the 2/3 power raised to the negative 3 power. All right, now the negative exponent of negative 3, that negative means that you flip this whole fraction upside down and then raise to the 3rd power. Oops. By the way, I'm sorry, let's go back to this one. We were supposed to only use positive exponents, so we could write that x to the negative 1/3 power is x to the 1/3 in the denominator here. All right, so focusing on this example, part B. So we took the reciprocal of the fraction, taking the 3rd root, and then, of course, the power of the quotient is the quotient of the powers, all right? And then, of course, 3 times 2/3 is y to the 1/2 power. 3. Now, you're going to distribute this power of 3 to the 2 and to the x to the 1/3 power. So, now 2 to the 3rd power is 8. X to the 1/3 power raised to the 3rd power. 1/3 times 3 is 1. So you have y squared over 8x. Okay? That's as simplified as you're going to get, and you have only positive exponents. All right, now look at part C. For this example here, we have 9 times x squared times y to the 1/3 power over x to the 1/3 power y, all raised to the 1/2 power. So what you could do is you can just bring this power of 1/2, what that's on the outside of the parentheses, and basically multiply each of the exponents for these factors on the interior times the 1/2. Okay. Also, what you could do before you even do that, you could even take the, simplify this fraction by taking, x to the 2 power divided by x to the 1/3 power. 2 minus 1/3 is, what is that? It's going to be, 5/3 power, right? And same thing with the y's. You have y to the 1/3 power over y. So you have y to the 1 minus 1/3 in the denominator. So that gives you 9 times x to the 5/3 power over y to the 2/3 power. You could have just as well, folks, just distribute this 1/2 to each one of these as well. Let me do that real quick, and what you would have gotten. Now, basically, you would be taking square root of all the stuff. So in the numerator, you would have 3 times x times y to the 1/6 power over, x to the 1/6 power times y to the 1/2 power. And then gotten to where we're going right here. All right, so moving along here, at this point we have taken the exponent of 1/2 and distributed it to each of the factors in our fraction there. So that's what we've got right here. And then, of course, apply those powers of 1/2 to each one of these 3 factors here. And here we go. This is what we've got here. Now, notice up here we had x over x to the 1/6 power. That is your x to the 5/6 power here. Here's your 3. And, here in my fraction up here, you had y to the 1/6 power in the numerator, y to the 1/2 power in the denominator. So in the denominator, you could take the 1/2 minus the 1/6. Okay. All right, moving along here. Now, folks, for those of you who are headed out to calculus, one of the hardest aspects of calculus is dealing with the algebra. And it's this sort of stuff that students stumble with. Okay? But if you keep your head about it, it's not too hard. We want to combine all of this junk under one denominator as a single quotient in which there are only positive exponents. Now, you might be saying to yourself, I don't see any quotients, I don't see any fractions. Well, take a look here. There's that exponent of negative 1/2. All right, so let's start going through and simplifying stuff. By the way, this 2 right here cancels with this 2. And you can combine this x right here with this x right here. And this x squared plus 1 raised to the negative 1/2 power can be written as the 1 over x squared plus 1 to the 1/2 power. So you have the x squared over that. So here's what we've got so far, but now we need to combine these 2 terms so that you have a common denominator. So you basically are going to take this term there and multiply the numerator and denominator by this exponent, or this denominator, I should say. So like I said, all we need to do is just multiply this guy right here by x squared plus 1 raised to the 1/2 power over that same thing. And then combine those 2 fractions, multiply. Now, when you have x squared plus 1 raised to the 1/2 power times itself, essentially you get x squared plus 1, and then plus x squared, and that's going to give you 2x squared plus 1 over x squared plus 1 raised to the 1/2 power. And we're done. All right? All right, we might have to factor some expression involving a rational exponent. All right, so look for any common factors through here. So, for example, notice the 4/3. There's a factor of 2 right here. 4 is 2 times 2, and you have 2 right there. Also, you have x to the 1/3 power and x to the 4/3 power. So both of those factors have common factors of x to the 1/3 power. Okay, so also, by the way, you can rewrite 2 times x to the 4/3 power as, by multiplying top and bottom by 3. So you have 6 times x to the 4/3 power over 3. And then you could add those two fractions. And then pull out the 2, pull out x to the 1/3 power. So that's what we did there, leaving us with 2 times 2x plus 1 plus 3x, right? Because when you pull out an x to the 1/3 power from x to the 4/3, 4/3 minus 1/3 is 1, right? So you have 3 times x, okay? And also, of course, we had pulled out a 2. So 4 divided by 2 is 2, which is this 2 right here, and 6 divided by 2 is 3. And then multiply this stuff out. 2 times 2x plus 1 is 4x plus 2 plus 3x gives you this 7x plus 2 over 3 times a 2 times x to the 1/3 power. Okay? So that's it. A quick review on roots and powers. Okay, so now we are just about ready to launch into the actual bona fide material for college algebra. This chapter R has been a whirlwind review of the algebraic topics that you should have learned, not to make any value judgments, but a lot of people walk into college algebra not even knowing much of that material, or it's been a long time. So hopefully this has been a good review and a good use of our time. Now we are going to launch into chapter 1 with our next lecture involving linear equations. All right, we are going to continue going at a fairly rapid pace. And the chapter R quiz is posted. Some of you have already asked me some questions. How do you take it? Well, folks, you just go in. Let's go ahead and see if we can go in and talk about the quiz. Let's launch into Blackboard here. Okay, here we go. So let me get out of tablet mode and go into essentially PC mode here. Oops. I'm going to log into Blackboard. Okay. So anyway, I'm not sure what that white screen is. Probably has to do with my recording area. So locate the link for college algebra on Blackboard. Okay, so then locate the, sorry about that, locate the course content link to the left of your Blackboard screen. I'm not sure how much of this you can actually see. But then under quizzes on the course content page, here you have the quizzes folder. And here you've got the link for the quiz. And when you click on it, You see that you have 1 hour and 30 minutes. This test will automatically save. So folks, as you work your way through the problems, after you submit an answer for each problem, you will the computer system will save it, okay? But be in mind, make sure that you are ready to do this in one sitting. So make sure that you've, frankly, taken care of all your biological needs, and that you're comfortable, that you got your calculator, scratch paper, and it's open book, open notes. So make sure you have all the materials that you need, and then click on begin. And once you click on begin, it's self-explanatory. You'll give a question to you, you'll work it out, and choose the correct answer. All of these questions are multiple choice. 1 through 36. Make sure that you manage your time correctly, meaning that you don't spend any more than just a couple minutes on each problem. Now, some problems you can do pretty quickly. It might take you 20 seconds or 30 seconds. Don't rush yourself, though. But make sure, like I said, you perform good time management, okay? All right, and then at the end of the test, you'll submit it, and the system will automatically score and post your scores on Blackboard, okay? Under my grades. Okay? And you don't have to email me, tell me that you took your quiz. I'll know, I'll find out, okay? And then go ahead and start reading chapter 1. All right, folks, so that's it. And if, of course, you have any questions, let me know. Otherwise, I'll see you next time. Take care. Bye.